All right, so you've got three different things happening in this warm-up. Number one, obviously, there's only one way to do it. You got to finish your triangle. Two, you can choose between unit circle and your 45, 45, 90 triangle. And then three, I want you to practice both. So with number one, I got to find, because cosine is adjacent over hypotenuse, okay, I have the adjacent, but I need the hypotenuse. So I'm going to find it using the Pythagorean theorem. 1 squared plus 3 squared would equal c squared. 1 plus 9 would equal c squared, and c would equal the square root of 10. And then adjacent over hypotenuse would be 3 over root 10, and we always rationalize, so it would be 3 root 10 over 10. Questions on that one? Okay, so then when it comes to something like number 2, no matter what trig function I ask, if it's of one of your special angles, you could choose between unit circle angles or right triangles. If you're doing unit circle, for me, I like it because I memorize the coordinate points by the radians. I say 45 is the same thing as pi over 4. And at pi over 4, my tangent is 1. So if tan is 1, the reciprocal of that would also be 1. And that's the answer. If you're a right triangle person and you want to set it up, or you bounce back and forth between the two, 45, 45, 90, the opposite sides of 45s are 1s, and the opposite to 90 is root 2. Cotangent is adjacent over opposite. Doesn't matter which 45 you pick. Adjacent would be 1, opposite would be 1, and that would also be 1. So how you do those is completely personal preference and up to you. For number 3, I said to do it two ways, only because this is 30 degrees. So it would only work without a calculator if that was 30, 60, or 45. If it's any other angle, you'd have to have a calculator. But it said to find the height of the tree if the length of the shadow is 50 feet when the sun's at an angle of 30 degrees. Keep in mind, this is a question I would expect you to be able to draw if you didn't have the picture, okay? So opposite that 30 would be your A, and opposite the 60 would be A root 3. That's the side you're given. So if 50 equals A root 3, I'm going to divide both sides by the square root of 3. A equals 50 over root 3, and then we're going to rationalize it. It'd be 50 root 3 over 3. That's the height of your tree if kept exact, and it would be feet. If you did it with any other angle other than 30, 60, or 45, or it said round it, then we use SOHCAHTOA. So the H is opposite, the 50 is adjacent, and I would say the tan of 30 degrees equals H over 50. And then in the calculator, I'm going to do 50 times the tan of 30 degrees, making sure my calculator's in degrees, 50 tan 30. I get the height is 28.8675. If I told you to round it, I think I said nearest 10th, it'd be 29 or 28.9 feet. And if you multiply out the 50 root 3 over 3, you'd also get the same thing. So you could do both ways to check it if you had a special angle. If not, obviously, you'd have to use SOHCAHTOA. Okay? 4 is called trig functions of any angles. It's a lot of application of stuff we've already done and a couple new things. But really a lot of what we have done with our unit circle and then applying it, how do we change it for triangles? So we start with the overlap of SOHCAHTOA with a triangle inside our unit circle. So if I take a triangle inside my quadrants, okay, and I create it, let's say I start on the right-hand side. Say theta is here, okay? The x value is going to be my horizontal side, the y value is going to be my vertical side, and the radius closes it in. So if I wanted to find sine, it would be opposite over hypotenuse or y over r. If I wanted to find cosine, it'd be x over r, which is adjacent over hypotenuse, and if I wanted to find tangent, it's y over x. So you can either use your literal SOHCAHTOA, or you can learn that if the radius is not 1, well, even if it is 1, we can set up these ratios, but if it is 1, we just use y. If it's not 1, then sine becomes y over r. Cosine becomes x over r. Tan stays the same, it's always y over x. If the radius is not 1, and then we go to flip these, the cosecant becomes r over y, secant becomes r over x, and cotangent becomes x over y. So all it's doing is saying, okay, SOHCAHTOA, now move it around your quadrants. What's different in this section that we haven't had yet is that these are going to become including negative lengths. So if I'm in the first quadrant, both the X and the Y are positive because you're moving right and up. But in the second quadrant, you're moving left, which means that X is going to be a negative X. And then you're moving up, so it's a positive Y. In the third quadrant, you're moving left and you're moving down, which means both of these are going to be negative. And in the fourth quadrant, you're moving to the right and down, which means the X is positive, but the Y is going to be negative. In every single quadrant, no matter where you draw it, your radius is always positive. Okay, which is going to matter when you start to get a ratio. If it says the sine of theta is -3/5, you'd have to know which part of that equation or that fraction to keep the negative with. So if it includes the opposite side, the hypotenuse, which is your radius, that side is always positive. And then you would know where to assign the negative to. All right. So as a refresher on your degrees and radians, our positive degrees and radians move counterclockwise. Our negative radians move clockwise. If I wanted to know where something was negative, I can find where it's positive and just overlap it. So for example, if I said, where's -pi/3, I would find where it's positive and I would fold it like a hamburger, and that's where it's negative. If I wanted to find -2pi/3, I could find where 2pi/3 is positive, fold it like a hamburger, and it would be at the bottom where 4pi/3 is, okay? Same is true for degrees. So in degrees or in radians, you can find it where it's positive and then literally fold it top to bottom, and that's where it's negative. Or you can move in a clockwise direction. It's totally up to you. All right. The trig functions of quadrant angles. This is where you cannot use SOHCAHTOA. You cannot find the sine at 90 degrees using a right triangle because the opposite and the hypotenuse are the same side. You cannot find the tangent of 180 degrees because that's a flat line. So these you have to know your quadrant angles for. As a refresher, on the right is 0. On the top is pi/2 or 90 degrees. On the left is pi or 180 degrees. On the bottom is 3pi/2 or 270 degrees. What's the coordinate point at 0? 1, 0. What's the coordinate point at at pi/2? 0, 1. At pi? -1, 0. And at 3pi/2? 0, -1. So these are your sines and cosines, right? The sine is all the y's. So the sine at 0 is 0. The sine at pi/2 is 1. The sine at pi is 0. And the sine at 3pi/2 is -1. The cosine is all the x's. The cosine at 0 is 1. The cosine at pi/2 is 0. The cosine at pi is -1. And the cosine at 2pi/3, or 3pi/2, is 0. And then I encourage you to memorize your tangents as well because it will make your life easier. Tangent on the right and the left are 0, and the top and the bottom are undefined. So at 0, your tangent is 0. At the top, it's undefined. On the left, it's 0. And on the bottom, it's undefined. So these are like straight up memorization because you cannot use SOHCAHTOA. All right. So we're going to kind of combine a couple of things together today. Example 1 says determine the exact values of the 6 trig functions of each angle theta. So it gave you the angle, right? We're going to make this into a triangle. So 4, 3 means I moved to the right 4, and it means I moved up 3. I'm going to enclose my triangle. And theta is the little angle that is formed by your x-axis and the terminal side of your angle. Do you know your triples? What's missing from this one? 5. So as a refresher on triples, because you're going to get used a lot. 3, 4, 5 is a Pythagorean triple. Double it, 6, 8, 10. 5, 12, 13. 7, 24, 25. And 8, 15, 17. These are not the only ones, but these are the most common. If you don't know these, then you have to do the Pythagorean theorem. These just help you save on time. So because we know the missing side is 5, and it's in the first quadrant, so everything is positive, now I can find my 6 trig functions. What's the sine of theta? Three over 5. What's the cosine of theta? 4 over 5. What's the tan of theta? 3 over 4. And then for the reciprocal functions, we just flip them. 5 over 3, 5 over 4, 4 over 3. With me so far? Okay, go to B. So here's what's weird. Theta is out here, right? But we can't make a right triangle on that side. That would be an obtuse triangle. So what we do is we enclose the left side of this, always making theta. This is actually called a reference angle, which we're going to talk about in a little bit. But we always put the theta where the angle that's formed from the x-axis to the terminal side of the angle. And then because we move left, this is the negative 15, and we went up, this is the, negative 8. And then we went up to positive 15. What's the radius? What's the triple with 5, or with 8 and 15? 17. And because it's the radius, it's always positive. So now I do cosine theta, sine theta. Actually, let me do it in the same order. Sine and cosine. What's the sine of theta? 15 over 17. Good. What's the cosine? Negative 8 over 17. What's the tan? 15 over negative 8. And it doesn't matter where that negative goes. It could go in the front, on the top, on the bottom, as long as it's one of those places. Cosecant, we flip the sine, so it's 17 over 15. Secant, we flip the cosine, 17 over negative 8. And again, negative could be out front, in the top, and the bottom, doesn't matter. And cotangent, negative 8 over 15. Now this one takes it one step further. There's no picture, but it's the same kind of information. It's giving you the coordinate point that is the terminal side of the angle. So I just draw it. Where would negative 4, 7 be? Which quadrant? Second quadrant. I'm going to move left 4, so negative 4. I'm going to move up 7. And then I'm going to close in my triangle and put theta in the corner where the x-axis goes to the terminal side. Is there a triple with 4 and 7? No. So we got to figure it out. So I'm going to do, and I don't care if it's positive or negative 4, because when you square it, it's going to go away. So 4 squared plus 7 squared equals my r squared. 16 plus 49 equals r squared. 65 equals r squared. And r is the square root of 65. Again, always positive because it's the radius. So now the sine of theta is 7 over square root 65, which has to get rationalized. Cosine, negative 4 over square root 65, which also has to get rationalized. And the tan negative 7 over 4. And then we flip them to get the reciprocal functions. But we want to go back to before we rationalized. Otherwise, we're going to have to re-rationalize that square root of 65. So I go back to where it said 7 over root 65, and I flip that one. I go back to where it said negative 4 over root 65, and I flip that one. And I go back to where it said negative 7 over 4, and I flip that one. Questions? Okay, we won't go all the way through, but look at B. B says 3, negative 4. Which quadrant is this in? Fourth, right? To the right, 3, down 4, close it in, put theta in the corner. What's your radius? 5, positive 5. Do you know how to get the trig functions from there? Are we good? Yes? Okay. All right, now let's talk about this little acronym. So this acronym helps you learn the signs of your trig functions, okay? In the first quadrant, because both the x and the y are positive, all the trig functions are positive, so it gets an A. With the acronym, we're talking about just our initial parent 3 trig functions, sine, cosine, tangent. So in the second quadrant, our x is negative, but our y is positive, which means the sine is positive. The tangent would be negative. In the third quadrant, both the x and the y are negative. So cosine and sine are negative, but the tangent would be positive. And in the fourth quadrant, your sine or your cosine is positive because it's an x. Your sine is negative and your tangent will be negative. So this one gets the C. So of your initial 3 trig functions, this letter represents which of those 3 are positive in that quadrant. So it says all, if in your book it says all students take calculus. It also says, which I hate snakes, so all snakes tease chickens is never something that I would want to remember. A smart trig class, okay? So now we apply it. Example 3 says name the quadrant in which theta lies if cotangent is greater than 0 and sine is less than 0. So if I use the all students take calculus, wink, wink. Cotangent would have the same sign as which of my original trig functions? Tan. So this is the same thing as saying tan is greater than 0. Which of the 4 quadrants has a positive tan? The first one and the third one. Now go to the second piece of information. Sine is less than 0. That means sine is what? Positive or negative? Negative, and which of the remaining 2 that we've already narrowed it down to would have a negative sign? The third quadrant. Good. So this is quadrant 3. If you write it in, like if it's an open-ended answer, I don't care if you give me the number or the Roman numeral of 3. Obviously, just know what the Roman numeral is if it was multiple choice. Questions on that one? So sometimes it'll say which quadrant or quadrants because the answer could be more than one thing. Just pay attention to that. All right. Example 4. Now it's giving you an actual trig function's value. It says given that cotangent of theta is negative 4 over 3 and sine of theta is greater than 0, find the following. So I'm going to draw a triangle, but think about what you need to do first because negative 4 over 3 could be negative 4 over positive 3 or it could be 4 over negative 3. And that's why they have to give you this second piece of information. So if cotangent is negative and sine is positive, which quadrant am I in? Second, where sine is positive and cotangent or tangent is negative. So now that tells you which part of that fraction gets the negative. The 4, good, because I'm moving left and up. So it's a negative 4, a positive 3. I close in my triangle. I put theta in the corner. And what's the radius? 5. So the sine is What's the sine of theta? 3 over 5. What's the cosine of theta? Good. What's the secant of theta? Good. And the cosecant of theta? 5. Good. 5 over 3. So they have to give you enough information for you to know which part of that is negative. If it's sine or cosine, then the top has to be negative because the bottom is the hypotenuse, and the hypotenuse is always positive. But if it's anything, if it's cotangent or tangent, you'd have to know which part is positive and which part is negative. Still good? Okay. Same kind of question, completely different information at the beginning. The terminal side of theta lies on the given line in a specific quadrant. Find the values of the 6 trig functions of theta by finding a point on the line. So it literally says that the terminal side of this angle lies on the line y equals 3x. If I was to graph y equals 3x, how do I start? How do you start graphing a line? This one, my b would be 0, right? So I'd start at the origin. And then what? Up 3 and over 1 because my slope is 3 over 1. Up 3 and to the right 1. So that is the terminal point of my angle. So I'm going to close it in. I'm going to put theta in the corner. I went up 3 and I went to the right 1. So now I have the 2 sides of my triangle. How do I find the remaining side? Pythagorean theorem again, 1 squared, 3 squared. We've done this. This is 10. So r is the square root of 10. And then it wants you to find all 6 again. So sine opposite over hypotenuse, which gets rationalized. Cosine adjacent over hypotenuse, which gets rationalized. Tan opposite over adjacent, which is just 3. And then we flip them to get their reciprocal functions. Cosecant, flip before we rationalize, root 10 over 3. Secant, root 10. And cotangent, 1 over 3. What do you notice about the tangent and the slope of the line? They're the same. And that will always be true because think about it. Tangent is your y over your x, and the slope is your change in y over your change in x. So those two things will always be the same. We still good? Yeah. Now we go back to our quadrant angles. This guy should be over here. So see if you could do this, literally trying to picture it in your mind without having to write it out. If you have to write it out, that's fine too. Like draw out your quadrants. But what's at pi? What coordinate point is at pi?
0,
Flip it. -1, 0, right? What's the sign there? Okay, we need to write it out. Sorry. All right, there's our coordinate point, right? What part of that is the sign? The y. So what's the sign at pi? 0. All right, for cotangent, cotangents are the reciprocal of tangents, right? So what's true about the tangents on the right and the left? They are, on the right and the left, they're zeros. On the top and the bottom, they're undefined. So if 3 pi over 2 is at the bottom, what would be the reciprocal of undefined? 0. Does that make sense? If we flip undefined, it would be 0 over 1, right? Undefined is 1 over 0, or anything over 0, but in this case, 1 over 0. Okay, last thing we're going to talk about today are reference angles. So a reference angle of theta is the acute angle theta. This little apostrophe is read as prime, formed by the terminal side of theta and the horizontal axis. to find the reference angle, we're going to find the difference between the x-axis and the angle. So the first thing we're going to do is figure out what quadrant our angle is in. And to do that, we use the rules we used last week. Is it between 0 and a half, and 1, 1 and 1.5, or 1.5 and 2? Once you know that, then you're going to follow these rules. In the first quadrant, your reference angle is the same as theta. So in the first quadrant, we leave it alone. If my angle is in degrees between 0 and 90, that is the reference angle. If my angle in radians is between 0 and pi over 2, that is the reference angle. I leave it alone. If it's in the second quadrant, then I subtract it from pi or 180. So the reference angle equals 180 minus theta, or the reference angle equals pi minus theta if it's in radians. So this could be something like 100 degrees. 100 degrees is in the second quadrant. To find the reference angle, I would do 180 minus 100, and that is 80 degrees. In radians, this could be something like 4 pi over 5. 4 pi over 5 is bigger than a half, but less than 1, so I would subtract that from pi, and I'd get pi over 5. In the third quadrant, so if it's bigger than 1 pi, but less than 1.5 pi, or bigger than 180, but less than 270, then I flip that. I say the reference angle is theta minus 180, or it's theta minus pi. And in the fourth quadrant, where it would be bigger than 1.5 pi, but less than 2 pi, or bigger than 270, but less than 360, I do 360 minus theta, or 2 pi minus theta. There is a special trick to all your special angles. If it's an over 2, and over 3, and over 4, and over 6, so those are your special angles, then the reference angle is always that pi, like pi over the denominators. What's happening with my stylus? Okay. So if I said that my original angle is 7 pi over 2, my reference angle is pi over 2. If I said the original angle was 11 pi over 6, my reference angle is pi over 6. If I said my original angle is 131 over pi over 3, my reference angle is pi over 3. So the special ones, which are over 2, over 3, over 4, over 6, the reference angle is always pi over them. Okay? Anything else you have to check to see where it lies. So for example, if I said that theta was 4 pi over 7, I got to figure out, this is definitely less than 1, but is it less than a half or bigger than a half? So 4 over 7, is that in between 0 and a half, or a half and 1? It's in between a half and 1, because 3.5 over 7 would be a half, right? So it's a little bit bigger, which means this is in my second quadrant. And to find the reference angle in the second quadrant, I would do pi minus 4 pi over 7. So this becomes 7 pi over 7 minus 4 pi over 7, which is 3 pi over 7. If I had said it was 11, let's say theta is 11 pi over 7. Now I know I'm definitely in third or fourth, but I want to see where it's cut off. So I'm going to take 11 over 7 and I'm going to convert it into a mixed number. What's 11 over 7? 1 and 4/7 pi. So is 1 and 4/7 in between 1 and 1.5, or is it in between 1.5 and 2? It's in between 1.5 and 2, so it's in the fourth quadrant. In the fourth quadrant, I do 2 pi minus 11 pi over 7. So that becomes 14 pi over 7 minus 11 pi over 7, which is 3 pi over 7. So if it's a special angle, and oftentimes it is, I just do pi over 2, pi over 3, pi over 4, pi over 6. If it is not a special angle, then I have to figure out which quadrant it's in and then follow the rules I gave you. Leave it alone if it's in the first quadrant, subtract it from pi if it's in the second quadrant, subtract pi from it if it's in the third quadrant, and then subtract it from 2 pi if it's in the fourth quadrant. If it's a reference angle in degrees, it tends to be pretty easy. You just got to figure out which quadrant it is, and then you use 180 or 360, okay? But these answers have to be between 0 and 90. Well, and including. It could include 90. All right, so example 7. Find the reference angle, theta prime. And then we're going to sketch theta and theta prime in standard position. So what did we say about an over 3? What would be the reference angle? Pi over 3. So theta prime is pi over 3. I'd get the same answer by realizing that's in the second quadrant and subtracting it from pi. You just don't have to do that work. So then it says sketch this in the same, in standard position. Theta prime, no, sorry, theta, the original one is 2 pi over 3, which looks like that. And the reference angle is pi over 3, which looks like that. The reference angle, when drawn, should always be in the first quadrant. Go to B, 9 pi over 2. What would be the reference angle? Pi over 2. How do I get to 9 pi over 2? Go back to what we did last week. What's 9 over 2? 4 and 1/2. So we would go around once, that's 2. Go around twice, that's 4. And it would be at the top. That would be 4 pi. That would be 4 and 1/2 pi, or 9 pi over 2. The reference angle is just 1 quadrant pi over 2.